Hi, I would like to explain you our biodistribution pipeline in 3 different videos. So in the first video, I will explain you how you can create your scan folder. So usually you have scans at different time points. For example, from a MILabs SPECT CT scan with a mouse hotel at 3 different time points. So for example, 1 hour, 4 hours, and 24 hours. And you have to create your scan folder in a special structure. You need to create your cropping file with the information of your dose, injection time, and weight. The pipeline settings with the information of your voxel unit and the scan start time, and how to perform the multi-subject cropping in batch. In the second video, I will explain you how to create the atlas files, what is needed to then run the AI tools for automated body, organ, and tumor segmentation. And in the third video, I will explain you how to compute your biodistribution curves in batch mode, for example, for percent ID, how to adjust the intensity of the selected class on the selected layer in batch mode, for example, to remove the mouse bed, and then how to save 3D screenshot series in batch for a nice presentation or publication. Okay, so let's start. So first, you will have your scan folder. So usually, for example, for the MILabs device, you get a results folder with your reconstructed CT. So I have here named the CT just as CT, and in my case, it's a GFF file, but it can also be an IFTY file or a DICOM file. And I have here my SPECT file, what is an IFTY file in this case. And important is that you have the same folder structure for all. So I have here two mice in one mouse hotel, M1 and M2. M3 and M4 in one mouse hotel, and I have 3 different time points, so 1 hour, 4 and 24 hours. So you can see I have the same folder structure already here. Every time it's the results folder, and everything is named as CT and SPECT, and that's the same for all the different folders. You can just quickly go through that, and you can see it's always named the same. What is then very important to perform the multi-subject cropping. Okay, so what I also prepared is my study details. So it would be nice if you can prepare that so you can just easily copy paste. In my case, I have 4 mice. I have the body weight in gram. I have my dose in microcurie, but it can also be in your case in megabecquerel, anything else. I have my injection time here and the scan time points for the first hour, the 4-hour scan, and the 24-hour scan. So the first thing that we do is to create our cropping file. So I go to the first scan and just double click on the CT and drag and drop the SPECT file. And first thing that we do is we have to define where is what mouse. So we can use the marker here in the left toolbar. And then we just use the middle of the mouse bed part here, so not the middle of the mouse itself, but of the mouse bed, for example, here and here, and we name this as M1 and this one as M2. If you're not sure where your mouse are positioned, you can also open the 3D scan and just turn around and see where's left and right, depending on the position. And then with this tool here, with the distance tool, we have to define the width. It's enough when you do that for one mouse. Then a height. And in the coronal view, we can also define depth. Okay. And then we go to modules, nuclear, multi-subject cropping. And as we have used markers here, we can go to use markers. And then you see you have now M1 and M2 created. And what is important now is the cropping info here. So you have the width, the height, and the depth. And you can also work here now to give it the weight of the mouse and the scan time point and so on. But you are much faster if you later work in the file itself. So I will just save the template now. I will save it as cropping. You can name it as you like. Important is that it's always the same. And when we now check the folder here, we can see there's our cropping file. I just want to have the cropping file here, not in the results folder. And when we open the cropping file, you will see that we have now M1 and M2. We have the injected dose. In my case, that will be microcurry. So I would just change that here. We have the weight in gram, the injection dose measurement time point, and we have the cropping information. So I will now to the study details. Just copy paste dose. Is it here? Yeah. Then the weight and injection dose measurement time is the 22nd of October at 8:30. 8:30. So same for mouse 2. And what we also change here is the subject name to M101 hour. And also here M201 hour. Then we can save that. And if you have, so as I have a subcutaneous tumor model in this case, just later on to run the AI tool for the tumor, it's important to have in the cropping file also the tumor position. And this is here, the right shoulder. Yep. Right shoulder. But you can also do that later. Okay, I will save that. Then just close this one. I will copy paste this to the next time point of mouse 1 and 2. So 4 hours time point of mouse 1 and 2. And the only thing that we need to change is that this is the 4 hours time point, as the dose weight injection time will be the same. Save, copy paste to the 24 hours time point for mouse 1 and mouse 2. And change here that it's the 24 hours time point. Then we do the same for our 3 hours, for mouse 3 and 4. Copy paste. And then we need to change here that it's mouse 3 and mouse 4 for the first hour. And here we now copy the dose for mouse 3 and mouse 4 and the weight. The injection dose measurement time will be 22nd of October at 8:55. Save. And then again, we copy that one to the 4 hours time point for mouse 3 and 4. And then again, just change that this is 4 hours. Of course, the more mice and more time points you have, the longer it takes. But it's absolutely worth it to then run everything automatically. So these are the manual steps that you need to do at the beginning. But I would say it goes quite fast. Okay, then we have the cropping file for all. What we then need is the pipeline settings. The pipeline settings you can create in MILabs. So I still have open the CT and the SPECT file. We go again to modules, but now to nuclear and multi-subject cropping batch. Before we were in multi-subject cropping. So we go to batch. And here there is a button create pipeline file. So first we need to select the directory where we are. These are our scans, and then we can go to create pipeline files. So what we need is the scan start time of the overlay. We will need the isotope, the overlay voxel unit, the underlay file path, and the overlay file path. And depending on your scans and the scan settings you used, you can also perform downsampling of the underlay and overlay. In my case, I will do that. And if needed, you can also interpolation, overlay voxel size, and underlay or overlay scaling and offset. So we have everything that we need. We will now just check the scan start time. So we go to the prepared study folder again. So the scan start time for the first time point is 22nd of October at 9:20. So I will just change that here, 22nd at 9:20. Our isotope is lutetium, and I would like to have it in becquerel per ml. My underlay file path is in results CT, and my overlay file path is in results SPECT file. I would like to have a downsampling for the underlay of 1 and for the overlay a downsampling of 2. Then we can save it as pipeline settings. Also here the name doesn't matter, but it should be the same all the time. Pipeline settings, it will be saved as an ini file, that's right. Okay, created successfully. In your first scan, there are the pipeline settings. And when I open that one, you can check downsampling overlay by 2, underlay by 1. Our isotope is lutetium. My overlay scan is in the results SPECT folder. That's right. My underlay is the results CT folder. And the scan start time point is at 9:20:00, and the voxel is becquerel per ml. Then we can save that. And also here, copy paste to the next time point of mouse 1 and 2. Open it and just check in our table for the 4 hours time point. It's the scan start time is the 22nd of October at 12:20. So I would change that to 12:20. Then there's nothing else we need to change because all the names are the same. So, and here it is the 23rd of October at 8:20. So change that 23rd to 8:20. Save. Then we can do the same for mouse 3 and 4. We have the first hour time point at 26th of October, 9:45. Change it to 9:45. Save. Then the next one is at 12:45. And the last one is 23rd at 8:45. 23rd October, 8:45. Save. Okay, now we have everything prepared. And we still have the CT and the SPECT open, but you can also open it again. But now we go to modules, nuclear, again to multi-subject cropping batch. We again choose the input root folder, which are our scans. And we select the cropping file. We select the pipeline settings. And we select the output root folder. I will just quickly create that. So we have our scan folder, and we need to create an output root folder, and I will just name that sorted. So select directory, and we will use the sorted folder. So now you need to define what you would like to have. So you can create an SUV image, %ID per ml image. You can create the file format. I would recommend to have it as our own Grace file format, but of course you could also select Nifty, DICOM, or whatever. Then you could make a dry run. I will just do that because then you can see if everything is going well. That looks quite good and it goes super fast. If there would be anything red, it would be written if there's something wrong in your cropping file or in the pipeline settings. That looks fine. Then we will unclick the dry run and do the real run. So we go to crop again. And now you will see that in your sorted folder, for every mouse, there will be a folder, and also for every time point. So the first hour, 4-hour and a 24 hours time point. And in every time point, you will get your underlay GFF. So this is your cropped CT file, in this case for mouse 1, first hour. Your SUV file, %ID file, and overlay, in this case, and background PML. So everything that you selected here will be created here. And this for every time point and every mouse. Okay. Yeah, this is what I would like to explain in video 1. And have fun to try it out. See you in the next video.